Here are some more videos from our stair building education series. Let's go ahead and get started with our first video. In this video, I am going to provide you with a few ideas of things that might help you out and a few problems you could run into when trying to create a stronger post for some type of an exterior stairway that might be going up to a deck or a landing. Now, I have came to plenty of stairways where they just simply attach a post down to the concrete with a small base, maybe a standoff base plate. Maybe they, put a strap across here to tighten it in, or maybe even a framing anchor. And whatever they do, it creates a weak post, a handrail that you can actually move. Some of these I've seen them where you can move them about 6 or 7 inches in either direction. They're brutal, Now, is this going to be a really big problem? I don't know. If nobody ever falls down the stairway or puts any pressure on it, then I would say no. The building inspector, however, is probably going to think a little differently. So let's go ahead and take a look at the first problem you could run into, and that would be the position of the base hardware. And you can see here where if you have it in this direction, you could have a problem. You might have to notch your stringer around it. You're not going to be able to drill a hole through it. But if we rotate it 90 degrees and put it in this position, then you can see here where we'd be able to drill a hole through it and provide a stronger connection for the post and the stringer. Now, I also need to point out that the corners of the stair stringers can break off. If you think about it, the grain of the wood is running in this direction, and that's usually where it cracks. And I can't tell you how many of the stair stringer tips I have broke off, and I just simply nail them back on. When I was doing a lot of track work, I just nailed them back on, and that was the end of it. But as we use the corner of the stair stringer, you need to be aware of this. If you take and you move this all the way to the top here, and you put enough pressure on this thing, even if you have your treads and risers nailed to it or screwed attached to the stringer, you can actually break it. It's a weak point that you need to be aware of when you are thinking about installing your post, the lower post for your deck stairs. And you can also see that the bolt isn't centered. It's off a little bit to so that it can connect to the stringer. So let's go ahead and put our treads and risers back on to give you an idea why I located the post, or both of the posts in these areas, and that was to make sure that they lined up with the tread, or the riser, front of the tread. And you can locate these posts wherever you want to. I'm just giving you an idea of what it would look like if you lined it up with the first riser or the bottom step. In our next example, I'm going to go ahead and rotate the base plate here 90 degrees so that it is just like this one here, and we can drill a bolt or a hole through all of the stringers and the post so that we can run an all thread through there. And don't forget, your all threads come in different sizes, and you can use connectors to screw them together. So if all you have are 2-foot all threads, you can get a couple of them and use the connectors to fasten them together and make them as long as you want to. And again, this is a simple and easy method that you can use. Is it going to create the strongest post support? No, it's not, but it's going to be stronger than the one we just looked at. And of course, another thing you need to take into consideration with this type of design will to make sure that the bolts do not interfere with each other. Just another thing on the long list of things to keep in mind, possible problems that you could have. If you could just imagine the bolts here being a little lower, or this needed to be a little higher, and you're like, perfect, I'm going to pre-drill my stringers, and you're like, oh no, that's not going to work. And of course, you could always do something like this: line all the stringers up, stack them on top of each other, and drill a hole through all 4 of them at once. That would be an easy way to do that. Just make sure that the holes or the bolts aren't going to create a problem. Let's go ahead and put the post back on there. Give you another view of it there. Next up on the list, two more examples. One where you're going to have a shorter all thread and a block. You're going to be using two of the stringers. Same method, just shorter. You're not going to have something running all the way through. And of course a heavy duty angle bracket. And you might have to have something made if you can't. This one here has another section added to it to create a little more strength. If you just take and get a lightweight angle bracket, you know, when you put some pressure on this, it's gonna move. So heavy duty would be the key there. And of course using the bolts, trying to get them spaced as high as you possibly can for the most support. And of course an example of what we're doing here, stopping the all thread a little shorter, putting a block in here to provide us with a little more stability, create a stronger section. And here you can see where we are going through the two stringers. So this right here is going to be a nice support. And I've actually seen them do stuff like this with hold downs. And I might make another video on that, show you how that is done. I'm not going to use that in this video. It doesn't seem like it's going to be as good as moving the post back a little bit. But again, it's what type of design you're looking at. If an architect comes in and says, hey, I want the post right here, you're not going to have a lot to work with. And of course, here's what I'm talking about. Moving the post back a little bit so that you can use more of the stringer. You know, you have more to work with instead of this little space of 4 or 5 inches. You know, if you have a 6-inch riser, something like this is going to be 4.5 inches. That's not going to be a lot to work with. Even if it's 7 inches, you're still looking at 5.5 inches for this. So this, move the post back. You can double block it on each side with something like this. And again, you can see where you can run the handrail, top of the board, through. It's going to be like a cantilever. This post is going to provide you with a stronger handrail, something that's not going to move as much. And it's going to cantilever over here and pick this post up. Now you can always add something to provide a connection to make this a little bit stronger. But if we don't use this and we just use this one here, and we can bolt it however we want to together, there's a good chance you're still going to be able to move this. When I go up a little further like this, and I have more of the stair stringer to bolt it to, it's going to be a lot stronger. So this would be the way I would build something like this. If I needed it to be strong and I wasn't involved with some type of a designer. You know, you can make your suggestion to an architect or a designer, but they might not want it. They might not. This does not look that attractive to have a post back, you know, a foot or 16 inches, something like that, and then having another post in front of it. It doesn't look as good as having a post at each end and then all of your balusters in between. And here we can see where we just simply bolted the post to the stringer. And you're going to get your strength. It's not just in the stringer. Once you nail your treads and risers to the stringer, you're going to get a little more strength out of it. So you can just bolt it. You don't got to go with the all threads. You don't got to tie to the other stringer. And then, of course, bolt the bottom to the post also to get something a little stronger. Give you an idea what the post base looks like. I'm also going to show you what a stand-off plate would look like. So again, pay attention to what I did here. I'm using the 2x4 for the treated, and I'm extending it past. And it's working fine for the back. So instead of having a base connector, I just went ahead and ran the treated past. And this one here doesn't look as good. It's a little off. So, but pay attention. I'm going to fix that here in a second. So this one right here, it's back because it's even with the front of the stringer. But we can solve that problem by moving the treated forward. And then we're going to set our riser on top of it instead of in front of it. So again, we're redesigning the handrail system, the stairs, so that the post can sit on top of the treated. So both of these are running through and lining up with everything. And you have your angle bracket here. And of course, before we had the angle bracket on top of the treated. Here we have it moved over a little bit, but something like this is still functional, still could work. Same situation here. Moved it forward, give you an idea. The post is in the same spot as it was before. Bolted in. And here's our standoff base plate. So a lot of people use these. I like using them too, but I wanted to throw it in here, give you an idea of what it would look like if you didn't want to run the treated through and use a standoff plate. And this could be a problem depending on how much rain and snow you get. You might want to use a standoff plate, or you might want to use the base plates or base connectors, the heavy duty ones, instead of running the treated lumber through, so you don't have to worry about stuff rotten and deteriorating, stuff like that. So again, these are just suggestions. Let's go ahead and put the treads and risers back on to give you an idea how it sits on top of the treated. You know, if you don't like this look, you're not going to do it, obviously. Going to have to choose one of the other methods. But here we can see where the riser still lines up, even with the front of the post, just sits on top of the treated. Now, another thing I want to point out is that you can always use thicker handrails, the top plates. And here I have a 4x4. You can always use a 3x4. But if you're looking for a little more strength, and maybe you're going to move this back a little further to create something, because you just don't have enough, lumber to attach it to. You got to move it back to the third string or something like that. Then maybe a 3x4. And you could always shape it. You could router the top or put some shaping in it, but you're going to have a stronger board than a 2x4 when you go to a 3x4. And of course, a 4x4 would be stronger than a 3x4. For something else, just another idea of something that might provide you with a stronger handrail. Now, that's it for this video. If I do make another one, and I am pretty sure I'm going to make one eventually, I will put a link here to it and give you a few more ideas. There are a lot of different ways you can connect the bottom of these posts to the stairs to make them stronger. It's just some of them don't seem to work as well as others. In this video, I am going to provide you with an idea how you can design a flared stairway. This would be at the bottom of the stairway. It's a section of the stairway that would curve out or flare out. Now, first thing I want to do is just give you an idea what a straight set of stairs looks like, the floor plan and the stairway. Now let's draw some lines on the floor. And in this example, we are going to go with 1/4 of a circle. We're going to need a center point on all of our flared curves. So we're going to need to locate this somewhere. And I'm going to provide you with one other example, but you should be able to get an idea from that how to design the stairway to create the flare. And you can locate the center of the circle in a variety of different spots to get a different design. So that is the nice thing about this. So here's our 1/4 of the circle that we are going to be using. And let's go ahead and zoom in on this. At a close-up, we can see the flare here. We just need to draw some lines. And you can extend the treads however you want. But I drew this stairway here. It's not going to be a bad idea to start with a stairway design like this. Start with some square treads, everything straight, then draw your curve, and then extend these lines across to create these steps. And that would look something like this. So we got rid of the lines that were going to be, or that were here originally, and have a flared layout. So again, straight, flared, not too difficult. This is the only section you're going to be modifying on a straight stairway. And it should look something like this when you build it. 2 different stairs. And again, the straight stairway is just here for an example to give you an idea. You know, you could take the straight stairway and start with that. You could lay everything out for a straight stairway, then build the flare, or you can do it all at once. You can draw the circle first, you can draw the bottom half first, whatever you want. My job is just to provide you with an idea how to do it. So here we have a large flared stairway. Not going to be a real common stairway to see something like this. Kind of a less of a curve is probably going to be more common. Now let's go ahead and start with the straight stairway again. And then I will create my center point. I'm going to come out 5 feet, and then I'm going to line it up with the tread or the step here. Now yours, depending upon your stairway, whether you're going to line it up with the front of the riser, the back of the riser, the front of the nosing. If you have a nosing, a 1-inch overhang, something like that, you might need to line it up with that. So here we've lined it up with the tread, and we came out 5 feet. And then of course this is our circle. And obviously you don't need to draw the whole circle in. This is just for education purposes, but you can see right here where we got a nice flare. And that's going to provide us with a, in my opinion, a better looking stairway. Straight on this side, straight until it flares out on this side. So not that difficult. Do your own experimenting. And move the center point to the circle wherever you want. Draw a couple of different things. And again, if you can design it on a piece of paper or on some computer software like this, then you won't have to do a lot of figuring out in the field. So anyway, that's it for a flared stairway. Here's a quick tip for anyone who is looking for extreme accuracy when building a set of stairs, and that will be to avoid using this part of the tape measure to create an accurate measurement. Instead, add 1 inch to the measurement. So I was trying to get a 5.5 inch measurement. Move it back 1 inch, go to 6.5 inches, and then go to the 1 inch mark on the tape measure to make your mark. And you can see here where we have 5.5 inches. However, if I go back here, you can see where the tape measure is a little bit off. It's almost a 1/16 of an inch off if I'm holding the edge of the tape, which is often loose, and loose for a couple of reasons. I'm not going to go into the details on that, the reasons why the edge of the tape measure or the tongue is going to be off a little bit. So again, just simply add 1 inch. You can add 1/4 of an inch or a 1/2 inch, but it's usually easier for me to add 1 inch and then go to the 1 inch mark on the tape measure. And I'll even use this method here when checking my treads and risers when setting up my framing square or for other measurements that I need to be within a 32nd of an inch of. In this video, I will provide you with an easy way to calculate and figure out whether or not you can use pre-cut stringers for your project, or whether or not you're going to need to lay them out yourself to make them work for your project. And don't forget that I do have books on laying out stair stringers and building straight stairs at our website. Now, the first thing you're going to need to do will be to measure the length and height of your stairway, because we're going to need these numbers here to calculate the riser height and the tread depth. And the tread depth won't be a problem if the stairs don't need to stop at a specific point. However, the risers will. This is going to be the big problem here. And if you actually want each riser heights to be the same size, there's a very good chance you're not going to be able to use the pre-cut stringers unless you build the deck or floor to match the height for the pre-cut stair stringers. So that covers the risers. The next thing we need to do is think about the steps, if they need to stop at a particular point. And this is going to be common in new home construction or remodeling. Another thing we need to consider is local building codes that might require you to have a 10-inch or an 11-inch minimum step and a maximum height for a riser of no more than 7 3/4 inches. However, you would have to check with your local building department in your area to verify this information. And yes, this might seem a little silly, but I've seen it before. When someone who doesn't really know what they're doing needs to make the stairway stop at a particular point using pre-cut stair stringers. And yes, it works both ways, either having a small step at the bottom or a smaller step at the top, or a larger step at the bottom, or a larger step at the top. And the same holds true for the risers. I've seen stairways built with prefabricated stringers that have taller stair steps on the bottom, smaller stair steps on the bottom, and the same up here. Or you could even end up with both a small riser or a tall riser, a small riser and a small riser, or even a combination of something I can't even imagine, because somebody thought that a pre-cut stair stringer was going to work for their project, when in fact it did not. So you can always buy one stair stringer and then put it into a position that you think will work, and then break the level out and make sure that the steps are level, and that all of the tread measurements will be the same, and that all of the riser measurements will be the same. That's one way you can do it. Or if you're starting out with something like this, where you have specific measurements you need to work with, then you can simply start dividing a few numbers until you arrive at the length of your individual treads and the height of your individual risers. So let's go ahead and break out our calculator, and we have 3 foot 7.5 inches, and we're going to convert that to inches. So 12 times 3, that's 3 feet, equals 36 inches, plus 7.5 equals 43.5. And we can just divide this number by 7. I'm going to divide it by 7, and that's going to come out with 6.2. Now this is going to tell me that I'm either going to have 6 or 7 risers that will be around 7 inches tall for our stairway. So let's go ahead, clear this, and go back to 43.5. We're going to divide that by 6, and that's going to provide us with 6 7.25-inch risers. And you could always try dividing the next number lower or higher into the overall total rise to see what numbers you get for the individual riser. You might want to use one of those numbers instead. And now that you have the individual riser height, you can go down to your local home improvement center or lumber yard and see if they have a stair stringer that has at least 5 steps and your exact riser height or tread depth that you've calculated. And now for the bad news, if it does not, and it has 7-inch risers, or it's not going to have enough steps, then you're not going to be able to use it. However, you will be able to use it if it has more steps than you need, because you could always cut one of the steps off. And hopefully that makes sense. If not, rewatch the video or go check out some of our other videos on our website. I have plenty of videos on our website showing you how to calculate the individual riser height, tread depths, how to use a framing square to lay out a stair stringer, and like I mentioned earlier, even books that will help you build a variety of different stairways. In this video, I will be sharing one of my tricks of the trade, and that will be to provide you with a method to where you can gain another inch or even 2 inches sometimes, depending upon the length of the stairway and how much of a risk you are willing to take, because even though this particular stairway is going to be 1.25 inches shorter and use the exact same size treads, it won't have the same tread run, individual tread run, and it won't have the same overhang because we're going to be subtracting 1/8 of an inch off of the individual tread run. And that might not meet your local building codes. And of course, for those of you wondering, why would I even suggest this then? Well, that would be because it worked for me plenty of times in the past when I had to help the architect out because there wasn't enough room. I couldn't move the stairway in this direction and I couldn't move it in that direction, and we couldn't move any other part of the building. And most of the times the building inspectors didn't catch it because the stairway was still comfortable to walk up and down. So use this at your own risk. I'm only sharing it with you because there are a lot of things I learned about creatively adapting or constructing stairways when no other options are available. So again, I'm taking 1/8 of an inch off of the individual tread run. That's probably going to need to be in most residential type of construction. And of course, now would be a good time to throw in the fact that your building code might only require 9 inches as its minimum distance for each individual step. Where I live in the state of California is probably going to be 10 inches. And you can see the difference in these two numbers, even though you're not going to see a difference in this number. And this is usually the number that the inspector is going to measure. And if they do measure the overhang and it's off 1/8 of an inch, they might not even say anything. However, this could be a totally different problem if a lawyer is watching this video. So if you are a contractor, you are the stair builder, make sure that you get something in writing from the architect or the property owner to release you of all liability, because the last thing you want to do is be responsible for someone else's problem as the person who is just going to be the assembler of the product. And for those of you who aren't quite following what type of problem I would be solving, it would be something like this, where you can't move the stairway up because you have a minimum distance already here, and you can't move the stairway this way because you're already working with a minimum distance here. And even though I'm suggesting 1/8 of an inch, I really wouldn't recommend going any more than that because you could be creating safety issues for the people using the stairway. So if you can't move the stairway this way because of the minimum distance, and you have a wall here that cannot be repositioned or moved to solve your problem, along with a wall over here providing you with a minimum distance, for example, of a hallway that might be 36 inches. And they're not going to want to see the nosing of the stairway encroaching into this area. Then something like this might be your only option, especially if you're dealing with stairs in tight spaces. In this video, I will provide you with a couple of different methods you can use to put a nosing on a set of concrete stairs. And I believe in most of the videos I've made, I have not provided any nosing because most of the forms usually look something like this. However, that will not be the case in this video. And I've got to say that these methods are probably among the cheapest methods you can use to create some type of a nosing by simply using a few 1x6s or 1x4s. And that can be done by using a few boards like these. Here we have a 1x6, and you will simply attach it with screws or nails to the riser form board. And you can see here where after we pour the concrete, we're going to have a nosing. And in our first example, the nosing is going to be 2 inches tall. However, that's not always going to provide you with the best structural support, especially if you're using a wider board. Instead of a 1x4, you might use something that's 1 inch or 1.25 inches. And even though I think the 2 inches is going to be fine, I know the 4 inches is going to be a little bit better. However, I will leave that up to you. I am the messenger, and it is my job to provide you with the methods. It will be your job to figure out which one of these you want to use. And the bottom two are among my favorite. This is actually my favorite here, because it's going to provide a nice decorative detail and plenty of support for our nosing. And of course, this won't be too difficult to do. You will simply cut a 45-degree angle, the length of the board you're going to use to create the nosing, and again, hopefully not too difficult, and of course what it looks like after we have removed the form board. So here we have a 2-inch tall by 3/4 inch nosing. Down here we have 4 inches by 3/4 of an inch. And if you want yours to be a little bit bigger, just use a larger board instead of a 1x4. And of course the 45-degree angle. And the height here should still be 2 inches. And of course the last one, and probably my favorite, would be this one, because it's going to provide you with plenty of concrete for structural support. Even though I'm not about to suggest this one won't be strong, it's just not difficult to tell that this one here and this one here is going to be a little stronger because it's wider. And there you have it. Some extremely easy methods you can use to create a nice looking nosing on your next set of concrete stairs. In this video, we are going to take a look at a set of stairs you might be able to build with a couple of planters that are also stepping to the same path of the stairs. Now, I am going to do a couple of these videos with different methods of assembly. However, I will not be providing you with step-by-step instructions on how to assemble it, because I do have other videos at our website that will provide you with that information. And the first thing I want to point out is that the tread does not need to stick past the planter box, and it could actually be even with it if that was the type of design you were looking for. And in our example, we have a 10-inch tread with a 1-inch overhang, and the riser height is 7.5 inches. Which means that the planter boxes would also be the same distance. And if you notice here, I have 2 stringers. That is probably not going to be enough. And in the next example, we will be adding a center stringer. And at the bottom here, I have a miter cut. And this cut, the way it is, might be difficult for you to do. However, it might not be if you cut a 45-degree angle at both ends, meaning this piece here and the other piece going all the way through. Because this might make it a little tougher when you have this overhang here. So again, if you want it to look really primo and impress all your fellow woodworker friends, then do it like this. And then they will probably wonder just how in the heck you did it. And we're just kind of taking the stairway apart, remove the planter face boards, and next up we will be removing the soil and then the side supports that will be holding the soil in to the planters. And I need to point out that these side supports are actually the same size as this stringer here without the notches in it. So you could simply grab your stringer pattern and then lay it on top of another 2x12 or whatever you're using for your stringers, and then simply mark the top 2 sections here and the bottom sections here to make it a little less complicated when building something like this. And of course, you will need to figure out how to design the stair stringers, and I do have other videos on that, along with a book on how to build and frame straight stairs that will be helpful. And when it comes to setting the stringers, you can simply put them in place and then make sure that each one of the treads are level to provide you with an exact location of where it's going to be located, and then drive some stakes into the ground and then attach the stringers to the stakes with either screws, nails, or bolts that go all the way through the stakes and the stringers. And keep in mind that any lumber touching the ground is probably going to need to be treated or ground rated, pressure treated lumber. Otherwise it is going to rot and you're going to have to replace it a little sooner. And of course, here's an example of the stakes with the screws in them. And make sure that you move the stakes back far enough. We need to move it back 1.5 inches so that our planter support boards that will be holding the dirt back will be able to attach to the stringers. So after you have this firmly secured and it's level, you can go ahead and install the treads, and those can be attached with screws or nails also. And probably going to be better to use galvanized stainless steel or maybe even zinc coated fasteners like the nails or screws for outdoor projects like this one. And then we can go ahead and install all of our planter support boards. And of course you can attach these boards to the stakes again with your choice of fasteners. And you can drive screws straight into the stakes or angle them into the stake. But either way you do it, make sure that the screws are actually attaching to something. And yes, I've seen plenty of people build this stuff where the screws are just barely on this side and really not doing anything. So another thing you can do will be to drive the screws in from this side, and it might not be a bad idea to pre-drill holes so that you don't end up splitting the lumber. And after you have the planter support boards where you want them, you can go ahead and attach the side boards to your planter. And of course that can be done with screws. And if you aren't using pressure treated lumber, I would suggest using screws so that you can pull any part of the stairway planter assembly apart and replace the damaged boards as needed. That's not going to be as easy with nails. And after you have everything firmly secured, you can backfill it with whatever soil you're going to use. Just make sure that you don't backfill the area under the stairs. And as part of the maintenance on this stairway, make sure that you remove any debris that could be touching your stair stringers, especially if it's construction standard lumber and not pressure treated lumber, so that it doesn't rot as fast as some of the other stuff in here that's going to be remaining wet over a longer period of time because you're going to be watering it to grow stuff. And the last thing I want to mention before wrapping this video up is that you can change the length of these planter boxes to make them a little smaller or a little longer by just simply increasing the length of your planter support boards. And of course you can do the same thing with the stairway. You can make it smaller or longer, or wait for our next videos and check them out if you're looking for a different type of design.